Hello and welcome, everyone. Thank you for attending today's IBM community webcast featuring the middleware community. My name is Jessica, and I'll be moderating today's webcast. Our topic for today is the resurgence of event-driven architecture. With that, I would like to introduce our presenter for today. We have Kim Clark, who's an integration architect and strategist. Welcome, Kim.
Hi, nice to be with you. And so today I really wanted to talk to you about how we're seeing a significant resurgence of the concept of event-driven architecture. My background is integration for more years than I care to remember, a good couple of decades. And over that time, I've seen how landscapes have changed in integration. And event-driven architecture is actually a pretty old term. I mean, it could go back a couple of decades, depending how you measure it. But we're starting to see it come to the front again as part of a number of the sort of current trends. A good way to look at the integration landscape over, as I say, perhaps the last couple of decades even, is through the lens that we use in agile integration architecture. That's something the technique we use in IBM to look at where clients are today and where they're trying to head to. This is a very simplified picture of agile integration, just to give you a flavor of it, but there's plenty of links at the bottom if you want to delve into it more. You can see on the left-hand side, integration back as it was at the turn of the century, if you like, very much a central integration team building integrations that were, any way of getting information from one application to another really would have had to go through that central team of specialists, and indeed through a central runtime. And then as we move into the middle, we can see the introduction of fine-grained applications, of API management to expose synchronous requests. And so that's sort of gradually moving us up. The API management came in sort of shortly after the service-oriented architecture period. And then microservices was around 2014 as we saw containers come to the surface. And with microservices in the application space, breaking applications up into smaller pieces, we also are now starting to see people breaking up the integration layer into smaller pieces as well. So that's a secondary effect that's happened there. And it's really in that moment where we started to see the introduction of events again as a first-class citizen in integration. And as we move to the third column, we start to see events not just involved in the applications themselves, but potentially being involved across application boundaries as the applications get decentralized out into different parts of the organization. And we're starting to see businesses owning their own IT, having their own autonomous decisions around technology in terms of application and integration, and using events as a way to help to decouple that. So we'll delve into that a little bit further. So why isn't it sufficient to continue using the exposed APIs that we have? So we've spent a decade or more through service-oriented architecture and API management exposing these wonderful APIs to get it data in back-end systems. But why don't we continue to use that? Well, we will. There'll definitely be a balance between using that style and using events. But the plus side of API consumption is that it's a very easy programming model. It's very straightforward from a consumer's perspective to call an API and get all the way through to a back-end system. The integration resolves the differences in all the data models and things right through to the back-end system. And you get the immediate response of the data that's there, or potentially making changes to the data that's there. Event streams turn that the other way around and say each time a change happens in a back-end system, let's propagate that change as a notification, as an event, and push that up to the surface. Now, microservice applications much prefer that because they can then become more decoupled from the back-end system. They're no longer reliant on the availability of the back-end system. They're no longer reliant on whether it can scale to the kind of demands that they may have. So it might be that you're now starting to hit the account balance for your bank account on a much more rapid basis than you ever were before. How do you keep up with those changes? How do you keep up with that constant need for fresh data at the upper tier of the applications? And so the events can bring that information to the surface, potentially storing it at the surface, and we'll talk about those patterns as we go on through. But this does bring into question if to surface APIs in an appropriate way, in a safe way, in a way where consumers of those application developers could self-subscribe, for example, to those APIs, then do we perhaps also need that same effect in event management? So do we need to start controlling the way that people can subscribe to events or even discover that events are available? So that's something I'll come back to towards the end of the presentation. But it's certainly an interesting factor in terms of the future of where event streams are going. So really, microservices is part of a big boiling pot of lots of different techniques in order to write things in a more cloud-native way so that they suit elastic, agnostic, cloud-native infrastructure more effectively. So we can make better use of that. And this is kind of a collection that I use quite regularly to talk about all the things that make something cloud native. I mean, initially we used to have things like 12-factor apps as being the sort of go-to for what does a cloud native application look like, but it's a lot broader than just how you write the application. There's methodologies and things like that in there too. And I think if we look through this now as a lens for why we start to see more use of events, the one that jumps out immediately is that we've got a need for strong decoupling, both between the individual microservices, but also between groups of microservices that we might class as applications. That's a fairly obvious one. Slightly less obvious is when we start looking at immutable deployment. Why is it that event-driven architecture can help us to have an immutable deployment that includes data? And that's subtle. That comes into some of the patterns that we'll be using in event-driven architecture as we go on through. And then, of course, the need to be able to sit on these elastic, agnostic platforms and so on. So I'll return to some of these factors as we go on through. But really, the motivation for a lot of the change in the way that we're building applications today comes down to these principles. And so I'm going to just recognize the fact that it's not exactly new, this idea of asynchronous communication. We've been doing it for as long as we've been doing IT, pretty much. Initially with files, and then latterly with messaging protocols like IBM MQ, of course, which is the one from IBM, and many of our customers across the world are using MQ to pass messages around asynchronously, and those could be described as events. But in a sense, what we've typically been seeing MQ used for is more of a transactional kind of interaction, more of a command. I want to make this thing happen in this location. Or potentially I want to use it as a request response kind of messaging as well. That is also a factor. But typically it's focused around sort of the traditional messaging's capabilities around once and once only delivery, and providing a simpler possible model for the consumer of the messaging capability, so that they can use that assured delivery without having to get too close to what's happening in the infrastructure underneath. And that then becomes, that gradually got expanded to doing things where you could use other patterns. So we certainly start to see topics and subscriptions and a publish subscribe model in the messaging space. So MQ supports publish subscribe, for example, but the way it supports that is subtly different to the sort of things people are using for events today. And as you can see, I'm hinting at Kafka. So Apache Kafka is the capability that most people are using when we talk about events today. Open source project, but it's been productionized in various forms. IBM's chosen to productionize it. It's IBM Event Streams. And we believe there's a complementary relationship between MQ and Kafka. So what does Kafka really provide? And I'm not going to go in depth as to what it provides, but I'm going to give you the key highlights. So Kafka, the really big difference is that it is based on an event log. So it holds a stream history of all of the events that have ever happened. Now, why is that important, and why does that somehow change the game? Well, it means, for example, one of the things you see here is scalable subscription. So if you want to see extensively large number of subscriptions to a topic, there's very little work being done by the Kafka servers in order to serve that up, because the consumers are responsible for what offset they're at, what particular part of that stream they're reading. And there's no transactional movement of, have you read this message or not, down to an individual subscriber, which there would be in the messaging domain, where in messaging it's all about transactions, it's all about specific, once only assured delivery. So we can scale the number of subscribers to hundreds and thousands of subscribers without much effect on those back-end Kafka servers. But that stream history has other effects as well. And it starts to lead us into using some of the patterns that have actually been around for a long time. We're starting to go back to some of these event-driven patterns that we can see. So what I'm going to do in the next part of this talk is to walk through some of those patterns and look at the subtleties of those patterns and perhaps even some of the pros and cons as well. And then we can see sort of why they've become popularized in the period of cloud native and microservice architecture. And I'm going to walk through them in what's not a chronological order by any means, because some of these things have been around for decades as patterns in their own right, but sort of a complexity order, if you like, in terms of starting from the simplest and gradually building upon those. And in some cases, it's actually the same patterns that are being built into the more complex ones. So the base pattern is obviously what Kafka does out of the box. So it provides an event log. You can publish events into that event log. You add on to the front of the event log. The consumers read from the back of the event log, and they try and catch up with the front of the event log. And they can move as fast or as slow as they like. They can go back and read events again. They can reset to the beginning. And you can do all sorts of clever things with that event log. So it could be an event log that captures absolutely everything that's ever happened. It could be a window. You could decide that the events older than a certain period of time are no longer interesting, and so you don't store them and you keep the control the size of the log. You can compact things from the past as well. So you could effectively say, well, if it's a log of all the changes that have happened to data in a particular table in my database, I'm only really interested up to, say, 2 months ago, I'm only interested in what the consolidation of those changes is, how compact them together. And then it's only from 2 months forward that I actually want to see the granular updates and deletes potentially as well. And so you can do lots of clever things just at the sort of the level of the event log itself. And that enables you to implement quite a number of interesting patterns with the front-end systems that are listening to those events and making use of those events. So that in and of itself is already pretty powerful. The fact that that history is there means that we can use that history. Now, of course, the consuming applications can use that history, but also so can the event processing things in the middle. So we could put something in as an event processor that looks at one particular topic from an event log, performs some kind of processing on it, and perhaps produces another topic as a result. That's the typical format. It could, of course, perform other actions, but it's quite often the case that we move from one topic to another. And that could be doing many things. And I've got a list here which is sort of going from the simplest to the more complex ones. So starting from the very basics of filtering, just filtering the messages that are coming off that topic. Perhaps certain things are not allowed to be seen by another topic. Redacting data within them and then posting the data without that data present. We could be routing between a number of different topics to segregate data up, or something like that. And then we get into the more complex things. We look at a window of events over time. So we might say, well, I want to correlate events and see when I see certain patterns of events occurring together. It might represent, say, fraudulent activity on a financial account, and you can see certain things happening, certain things in certain locations that could hint that this is fraudulent activity, or the time span between them, and so on. So some really clever things you could do there, and that brings you into the level of sort of real-time analytics, and potentially even using sort of machine learning models and things that could start to spot patterns that we perhaps can't articulate so easily in a deterministic way, but we can train a model to understand how to look for those patterns. So there's a huge amount you could do with that information. Now, could you have done that information if you just looked at the raw database? Well, somehow you would have had to have created this historical window and stored it somewhere, whereas in this case, we can just use the event stream for that. And it becomes a much more natural way of performing event processing. So that introduces a whole lot of new cases, which are very important. They're not specific by any means to microservice applications or cloud native, but they are more typical of the type of things that we're doing in data analytics in modern innovative applications. Now, this next example is much more typical of something that is quite important to microservice applications, and we're calling this projections. So the idea is that we take a projection of a back-end data store. So the back-end data store produces events as its data changes. They're all there in the event log for anybody to go and look at. And the consuming applications come along, read that event log, and build their own local database of exactly what the current things are. Now, this is interesting because the event log continues to be there. As you read the messages, they're not deleted as they would be with traditional messaging like MQ. And so this comes back to one of the cloud native principles. So this comes back to the fact that, effectively we can have an immutable stateless microservice component that if it chooses to, it could store the state of the data it's interested in memory. And then if we need to perhaps introduce a new version of that microservice component, then we can do so by dropping that component, doing a rolling update to introduce a new version. And that new version can come up and read the event log from an appropriate window of time to build up its local data store again. So it doesn't have to go to the backend data store to do it. It can do it from the event log alone. So there's a few things that come from this pattern, and a lot of them are related to taking pressure off the back-end system. So we don't have to make those API calls, for example, all the way through to a back-end system that might not be designed for the scale we have. It's constantly available. So we're dealing with the availability of the event log and indeed the availability of the local event store, rather than worrying about whether our back-end, perhaps a legacy system, actually has the availability we need. And we can introduce a much lower latency. So hitting that local data store can have the data in exactly the format we want, and it's always there. We can decide the availability of that local data store rather than having to rely on another system. So we can build on that pattern, and we can do something that's known as event sourcing. Event sourcing is where we effectively say, well, I'm going to build an application with new data in it. So this isn't working with an old application. This is building a new application. And instead of having a database as my main master storage of data, I'm going to actually have an event log. I'm going to have, for example, Kafka as that source of truth. And so I don't actually store anything in, say, a relational database or any other kind of database initially. I store it in the event log. And then when I start working out what the use cases are for reading that data, I start to build those into the local data stores. So we've taken the event stream projections concept, that's what's sitting on the top right. That's how we query the database, the data that's in our master data store. And on the left-hand side, that command implementation, that's receiving changes to the data. They're effectively just events that are appended to the event log. And if you haven't guessed already, combining these two things together is known as CQRS. So that's Command Query Responsibility Segregation. So it's a combination of the projections on the right-hand side and then this addition of the command on the left-hand side. And CQRS, if you like, is the way you implement an event-sourced application. So those two things sort of come hand in hand. Now, this in itself is quite a subtle pattern, and getting it to work is it has some really powerful advantages in terms of having the event history, allowing you to look at trends and perform event processing and so on. There's some, certain use cases are much better suited to an event-sourced application than they are to any kind of traditional data store. It's another form of data store, if you like. But there are some complexities to this, and certainly in terms of design, you want to make sure that you understand the boundary of who's aware of the fact that you're using event sourcing underneath. If we look at it from Domain-Driven Design, which is a book of over a decade old by Eric Evans, which is very as a resurgence in understanding of those domain-driven design concepts, it has the concepts of a bounded context. And the bounded context is where you're sort of talking the same diction, the same vocabulary and language, the same data models, if you like, within a particular area. We could call that area an application, if you like, although that term is not necessarily what we call it today. And the general practice is that you would expect to see the concept of an event-sourced application and CQRS happening within an individual bounded context. And so you'd fix it to within just that bounded context. Now, this is really important because as we start to potentially expose events outside of that bounded context, then we start to see that we need to perhaps translate those events, maybe filter them, maybe redact them. We certainly don't want to expose the exact events from within the bounded context because it's pretty much the same as showing your database. If you're showing the actual tables in a database outside of a given application, you always want a sort of anti-corruption layer between the two. So that brings me on to scope. So looking at this idea of a CQRS, this idea of command processing separated from reads, in the scope of an application, that would be classed as CQRS and it would be designed in a certain way. But what I often hear is a very similar looking pattern occurring across an enterprise, so not inside an individual application, but across multiple different pieces within an enterprise. And so you might, for example, have on the right-hand side there, that command store, incoming command store, might be something like the point of sale transactions in the stores of a retail organization. And they're being captured, and there's a whole system involved in point of sale, which is completely separate from the system that those transactions are then being represented to, perhaps to a number of different systems. One of them might be an inventory system, and that might be what we're seeing at the bottom of the right-hand side. And that might be then taking in those requests and placing them into an inventory database, a true database. So it's not event sourcing. It's actually a true database, and then it just happens to produce an event log off the back of that, which might be something we've implemented much later on. And that event log might not represent everything that's in the data store. It's not a source of truth in the way that it was in CQRS. And then those events might again be being translated before they get outside of the boundary of the inventory system. And as they go into the system at the top, that could be a replenishment system or similar. Shipping and ordering and so on. That then could be having its own data store, which looks a lot like an event stream projection, and to some degree it is. But again, it's being built off the back of events that are very different to we would have been implementing on the left. So I guess what I'm trying to say here is that there is a logical similarity between the left and the right-hand sides of this slide. But when it comes to the implementation, there's a lot more piece parts involved on the right, and it would it would be more recognizable to an integration specialist as integration patterns. You'd see probably API management involved. We'd probably see multiple different, perhaps multiple different event logs even. We've got different data stores involved. We might see traditional messaging involved here too. And I've got an example of this that we can talk to that's typical of retail customers that I've spoken to, where we see messaging as something that is traditional messaging, that is like MQ, as perhaps something that's in some cases more suited to being the type of asynchronous communication you might want in the stores, and then using perhaps the event log to enable you to transmit events around the multi-cloud architecture that you have deeper in the organization. And so we see the mechanism as well by which the messaging transfers things across those boundaries, those cloud boundaries, those domain boundaries, if you like, is different for messaging as it is for the event log. So the event log, for example, might be replicating the topics from on-premise to off-premise. And that's really powerful because you could have a desire to move all of your applications gradually to cloud. And as you do so, each application you move between on-premise and cloud can effectively continue to read from the same topics, and there's a replication of those up in the cloud as well. The messaging, on the other hand, is more of a messaging network. It's almost doing the same kind of thing as we know we can do today with sort of HTTP over TCP/IP for synchronous communication. We set up a channel network for the messaging network. And even if a store goes offline for a while, it still continues to persist those events. And then the channel network makes sure that they go to the right destination. So the channel network and the messaging network effectively says, oh, I know this particular application lives on premise. I'll start sending these down there. You can use things like MQ clustering to enable you to have the routing done fairly automatically. And we can put an incredibly light footprint in a store. So if you've got thousands of stores, then standing up Kafka clusters in each one of those stores is probably prohibitively expensive and complex. So having a lightweight messaging, I mean, MQ itself, in our freemium version in the background, what we're doing is provisioning MQ servers, MQ queue managers on like a 20th of a core in the background, 20th of a core. So that's, really lightweight capabilities, and we've got special licensing models to cope with that as well and things. So, there are complementary characteristics of these two different styles of communication. And of course, we can join the two things together. So the messaging could then be producing things that then end up on an event log and end up being made available as notifications that anybody can pick up around the organization. And vice versa, a topic could be sent to a messaging queue. Often you find that existing applications are already producing the events that you need as part of the MQ network that you've got connected up. And so sort of tapping into that and pushing those things to an event log is also pretty powerful. So I didn't want to finish with the patterns without mentioning the Saga pattern, although this deserves a much longer conversation in its own right that really steps into other disciplines than just integration. We've got the Saga pattern is really a way of performing interactions with multiple systems and coordinating those, and there's two different styles. Orchestration, where you have a sort of a first-class concept of the process, and then there's choreography, where you have a chain of different interactions that don't know about one another. They know what to do, but they put things into a temporary storage, like an event log or a queue, and then pass it on to the next one. There are two different styles of this. The Saga pattern's been around as long as databases and as long as distributed transactions. In some cases, you might be leaning more towards even business process management as a tool to handle these. But yeah, I needed to mention that, but I think it's a bit beyond the core topic of today. So just lastly then, I want to drop back and take a look inside one of these microservice applications. And here we've got multiple different microservice components. For the true decoupling, it might well have those microservice components having their own databases. There might be an event broker, an event log sitting for use within that application domain, that bounded context, if you like. And that might be owned by one of the specific components, or it might be used more broadly across components, depending on how you've scoped your context. But I think it's important to differentiate that from when we start allowing events to escape the boundary. And we probably do have a different kind of event going past the boundary, a domain event, if you're going to domain-driven design terms. And we have to ask this question, is that something that needs to be managed differently? What are the permissions associated with that? Who's allowed to listen to those events? Do they need to listen to only a filtered set of those events? How do we notify them if we're going to change the schema and so on? And it starts to look a lot like what we would have been doing in API management. And so we're seeing a kind of a gradual maturing of this space where we are today with sort of basic event distribution and the productionization of Kafka. and moving across into more easily consumed event streams that might be being used outside of an application boundary. And so that's really a different form of use of these things. And you need to understand the characteristics of a stream that you're listening to. You know, is it suited to building a projection from? Does it contain all of the information I might need if I want to have a secondary representation of a data store that's on the back end? Or is it a different kind of event stream that's perhaps more focused simply on notifications of events that are occurring, but it wouldn't suit the purposes of producing a projection? So characterizing event streams as well, having a portal through which I can discover them and subscribe to use them and so on. So seeing a lot of movement in that area. We've got research projects running at the moment, and we're working on new products in this space, which is a pretty pioneering area, really pretty exciting. So target architecture that people are looking to is more decentralized. It's sort of the third column across. I'm calling this a target architecture because I recognize that most customers will continue to have a lot of the centralized architecture that they have today for many years to come. It's only parts of their infrastructure and architecture that will be able to move to this more decentralized model. And so we'll see this as the target architecture, but spread across multiple clouds. I've barely even touched on the topic of SaaS applications, but you can see that events are a first-class citizen in this architecture, both within the microservice applications, as I've described earlier, but also, as we can see on this slide, fundamentally across those applications and being managed perhaps on those boundaries. Now, I've moved through a lot of concepts pretty quickly here, and I haven't really left enough time for Q&A. I didn't really expect to, given it's only half an hour session. That's really what how we expect these sessions to go. I can see a few questions have come in. I'm more than happy to catch up with people offline through the community, and we'll get that going in the background. Yeah, thank you very much for your time today. Hopefully that's given you some insight as to where event-driven architecture is being used, and the pros and cons in some of the patterns, and the distribution of where people are still doing events and compared to APIs. The two are definitely going to live alongside each other for a long time to come. So thank you very much for your time today, and that's me done.
Thank you again for joining us today, and we hope you have a great day.